I always found optical illusions interesting, but one thing I really want to do when I see one is change some properties to see if it still happens. So I've made many beginner-friendly JavaScript tutorials where we inspect different illusions. And today we'll be tackling the herring illusion, where those green lines appear to bend even though they're actually straight. We'll learn how to draw those rays using math and JavaScript and how to control different properties using sliders. Now, get ready to cross the lines of optical trickery. Get it? Because no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
We'll begin with the code editor open in an empty folder. I'm using Visual Studio Code, and we can create a new file here like so. Let's call it index.html. And this is going to be a light, beginner-friendly project, so all the code is going to go in this index.html. We start off with standard syntax, so the doc type, and then the HTML tag, and the closing tag, and the head section. And inside the head section, I'm going to add a title for the page. Let's call it Herring Illusion. And then the body here, just below the head tag. And the body is going to contain one canvas element. Now, if we save this file and open index.html in a browser, we're going to get not much. We can see here the title of the page appears in the browser tab at the top, but the canvas is not there unless you open the developer tools, and then you see inside the elements tab here, canvas. It's actually there on the screen, it's just transparent. So let's give it a quick style. I'm going to type here style border 1 pixel solid, and it's going to default to black. So if we go back and refresh, we will see the canvas on the screen like this. Let's make it bigger so that it covers more of the space here. I'm going to just align these a little bit better and write here a width of 700 and a height of 700. These values look good for me. And you can see the canvas now covering much of the screen here. And we can begin to draw the effect. But for that, we need to refer to this canvas somehow. We're going to give it an ID here as well. I will say ID is equal to my canvas. And now below the canvas tag here, we will begin a script tag where we will write JavaScript code. Let's close it also so we don't forget about it. And to draw on the canvas, we're going to need to get a reference to its 2D drawing context. So let's say CTX is get context 2D, like so. And how would we draw this effect? One component would be to be able to draw some rays coming from the center of the screen. So let's pretend we already have a function that does that, maybe draw rays. And here I'm going to pass the center of the screen as the width of the canvas divided by 2, and vertically the height of the canvas divided by 2. And then these rays should extend, but not forever. It's impossible on a computer. So I'm just going to put a value here, let's say 300 for the radius. Now, this is the function that we should implement, and it should be able to draw the rays. Let's start doing it here and give proper parameter names for those things, maybe center X, center Y, and radius. And I like to debug as frequently as possible, so before we start drawing the actual rays, let's draw a simple circle. We already have a radius and a center there, so that's all we need to draw a circle. And I'm going to do that using the arc method, centered at center x and center y, with the given radius. And the arc method needs two more parameters, the start angle and the end angle that we want to draw the arc. So a full circle means starting at 0 and going all the way to 2 pi, which is 360 degrees, but in radians. And let's stroke. And now if you save the file and refresh, you will see this circle with a radius of 300 pixels here. This looks about right. And to draw the rays, we already know the coordinates of this point, but we will need to also know coordinates of points along this circle at equal angles there. If we know the radius and the angle, those are so-called polar coordinates. But we need to have Cartesian coordinates. We need to have an x and a y for each of those values. And we can get them if we consider the unit circle. I'll show you. So here, let's go below the stroke and do a for loop so that we draw multiple rays. And I'm going to start the for loop using a as a variable for angle. And starting at the angle 0, I'm going to go all the way to 2 pi, so 360 degrees. And we'll increase this a by a small amount, let's say 0.1. 2 pi is 6.28 something, so 0.1 is going to give us a decent number of rays to start with. And let's go inside of this for loop and figure out the x and y coordinates on the circle using a and the radius. So we do that by typing x is equal to relative to the center x. We will add the cosine of the angle times the radius. And for the y, we will add to the center y the sine of the angle times the radius. And now we can move to the center x and center y and do a simple line to the x and a y that we just calculated. And below the for loop here, we can do a stroke. This will stroke all the individual lines we generate here. Now save the file and refresh the page to get this. And it looks quite nice, but if you're really careful, you're going to see that something is not perfect. This is the same, this is the same, this is the same, and this one is just a little bit smaller. And that's because this 0.1 here that we increase is not a fraction of 2 pi. And it would be nice for it to be so that we can control these spacings and they are always the same. But here it's up to you to think. Do you want to have a parameter, this angle spacing, or do you want maybe to have a parameter for how many rays to have in this scene? Both are possible, you just have to make a decision and implement. I'm going to show you how to add the count, the number of rays. So let's add here a fourth parameter to the draw rays function, and it will be count. And I will give it a default value. Let's give it a small value so that we can actually count how many there are. Let's say 6. And now we need to define that angle spacing based on this. So the way we can do it is just saying angle spacing is pi times 2 divided by this count. And we pass this angle spacing here when we increase a, like so. Now save and refresh, and we get 6 slices here. Kind of looks like a pizza. But one thing, again, if you are looking very closely, is this line is thicker than these lines. It looks more black. Do you see it? The reason for this is very technical, and it happens when we work with floating point numbers like this. It happens because a increases, and then at some point it becomes almost math pi times 2. But not exactly math pi times 2. It's a very small fraction that is different from that. I'll show you. I'm going to go here and just add a quick log to A, refresh, and in the console, you can see that the last value here, 6.283185 and so on, if we type math pi times 2, it's just a little bit bigger. The only difference is this last digit, 5 and 6. It happens to be still a little bit less than 2 pi here. So that means that this does execute and it draws this line here once when we have a is equal to 0 and once when we have a is equal to pretty much 2 pi. So basically 2 lines that are overlapping each other. You can solve this problem if you make this for loop go with integers instead. So using this count and going from 0 to count and then figuring out the a value based on that. Or I'm just gonna do a quick fix here by subtracting the angle spacing divided by 2. And this means that it's not going to go nowhere near close to that, but it's still gonna respect this angle spacing, so the last slice will be present there. Let's save, refresh, and now this line looks the same as the others, and the final value of 6.28 isn't printed there anymore. We can remove now this console log as well. And let's try setting this count to something bigger, maybe 60. And it looks really nice, I think. We don't need this outer circle anymore. So let's just remove this arc from here, like so. And these should extend outside of the screen. So I'm going to give it a large radius, like so. And now for the vertical bars. So let's just go here below where we draw the rays and start to draw 2 vertical lines. And these will be a little bit thicker. So I'm going to set a line width of 5 maybe. And let's give them a color. I'm going to say a stroke style of green. And first we move to the top and somewhere in the middle, but not exactly in the middle. We want a little bit to the left. And I like to use a fraction of this canvas width smaller than 0.5. So let's just say 0.4 for now. And the vertical value is going to be 0, the topmost point. And then we line to the same thing for the x. And the bottommost point, which is just the height of the canvas. So let's stroke, save, and refresh. And look at that. We drew a vertical line here, but I actually see it curving. Even with this one line here, it seems to bend. The illusion is already working. Let's add the other one, maybe at 0.6 here. To be symmetric, I'm going to copy these like so. And yeah, these lines definitely look like they are bending outward like that. Do you see it? Let me know in the comments. Now, this spread between these lines is something I would like to control to see if they are further apart. Does this affect the illusion or not? And these are very many hard-coded values here. So what we could do is just decide that we want to control the spread between those. And now we have a spreading factor here of the difference between these is 0.2. So basically 20% of the canvas width. And we could go up here and say spread factor is 0.2, and now we could multiply by 0.5, which is in the middle, and then subtract half the spread factor, so spread factor divided by 2. And the same thing for the second one here. And for the other one, we add the spread factor, and now we copy this for the last one as well. And we still have some hard-coded value here, basically this 0.5. If you want to change the offset, where is the center of those vertical bars, then that would be another parameter you have to take out. But I'm fine with it like this. And if we refresh, we don't see anything different. But if we modify the spread to say maybe 0.1, then this is now showing 10% of the whole width of the canvas here. And I can still see the illusion. Now you could control this maybe 0.3 like this. And maybe now it starts to break. I almost don't see them like that almost at all. But controlling that spread factor like this is kind of tedious. I would like to have maybe a slider here so that I can see many different values just by playing with the mouse. Let's do that. Below the canvas here at the top, I'm going to define an input element. And let's close it. And inside here, it will be of the type range. Now, let's give this a default value of 0.2, a minimum value of 0, maybe those lines can be overlapping each other, and then a maximum of 1, so 100%. And the step, we will increase this at the fine step, 0.01. Now, every time we change this range input, we will redraw using the value of this range. So we need to create a function for this. And I'm going to do it here and wrap everything inside this redraw function. So function, redraw, and the parameter here is this spread factor now. So spread factor. That means we won't need this one here anymore. And all of these I'm going to align to the right and close the function like so. Now if you save and refresh, you will see the slider appearing here. The page is empty, but if you move the slider a little bit, strange things happen. The canvas here, when we are redrawing, should be cleared so that we don't draw on top of existing things. So I'm going to do a clear rect from 0, 0 to the canvas width and the canvas height. Now we save, refresh, and when we move this, it's a little better, but you see the styles get messed up. And that's because the first time this redraws, when we move just a little bit, it changes the width and the stroke style to green. And then these values go inside the draw raise at the second iteration when we move a little bit more. So we really don't want to mess these styles up. We want to restore to what we had previously. And one way to do that is to call here ctx save. It's going to save all of these properties before we start to do anything. And at the end here, at the bottom of the redraw, we can restore so that we get those initial values and prepare for the next draw raise. In this way, we are going to get exactly what we want. And the only thing we still need to do is when we refresh or when we start the application, there should be something here. So basically redrawing at this 0.2. We can do that here. Save, refresh, and now there's something there, and of course the slider still works. Now let me teach you something else. What if you want to add another slider that controls how many rays there should be? We will have some problem with that. Because of course you can start here by saying, copying this, and saying that the default value should be maybe 60, the same count that we have now. Now the minimum, let's have starting at 1 and maximum 1000. Let's have really a lot of them as the maximum value. And the step we will just increase by 1 because this will be a count, how many rays it should have. But 1 is also the default value, so we can remove it. And here, this is the problem. Now redraw expects here the spread factor, but now we're giving it a count. The spread factor is still needed somewhere. So really here we should have another parameter appearing. But the problem with that is that we don't have the spread factor to pass it to that. So we could solve this in multiple ways, but the way I like to do it is to actually define new functions for each of these. So this one here is going to be, let's say, update spread factor. And this one here is going to be update count. And these spread factor and update count, they can be parameters here at the top. Let's say spread factor is equal to 0.2, and then count is equal to 60. Now here where we are defining the functions just below the redraw call, we can implement these and overwrite those default values based on the value parameter from here. So the spread factor is going to be equal to value. And then we can redraw using the spread factor and the count, which is a global there. Now, the same strategy will happen also for the update count, given the value, but here we update count to the value and then redraw using spread factor, which is available from above, and then count like this. Now, the redraw function here has the spread factor already, but it also needs this count, the second parameter. So I'm going to pass it here, like so. And when drawing the rays, this default value for count, we can actually remove it from here and pass the actual count here, like so. Notice the rays are still hard-coded. Maybe these should be relative to the size of the canvas here somehow. You can think about it. Hard-coded values like these are not good to have, really. Because if you will have a canvas that is twice the size, you get again that kind of circle border appearing there. So, yeah. Now, one more thing, when we call redraw here, it also needs two parameters. So let's pass the count here as well. And instead of just duplicating the value here, we can pass the spread factor. And now save, refresh, and this one controls the count of those rays, and this one the spread, and both of them work. But there are still some things with this code that are not fantastic, right? So one thing that I see here as a potential problem is this value set to 0.2 and value set to 60 and 0.2 and 60. And let's say that you decide, I don't know, to have a default value for the count to 1000 to begin with, and you do that. And then when you go here, it does look like that, like 1000 rays appearing there. Interesting patterns, by the way. But the slider is not matching that. The slider shows still 60. And moving it a little bit, you don't really know what value it was there, unless you play with it here and you end up to that. So to fix this problem, I'm just going to put here 60 again. I like that default value, but remove the default values from these inputs. Now, these will change the application so that, again, we have the default 60 rays here, but these are showing in the middle, so these are problematic. And you could give these an ID. So let's say ID is spread factor slider, like this, and this ID is going to be count slider. And after we have these values there, you can update the slider values using those parameters, like so. And the second one for the count slider, like so. And now we don't have duplicates for these. And it means that the issue we had previously doesn't happen. These are in sync, like that. And if we change this value to 1000 again, this shows the maximum value there. So it's much better. And everything still works. Okay, now it's your turn. Because if you just follow tutorials like this, it's not the same as trying to figure stuff out by yourself. So try to do more things here. Maybe, I don't know, change the thickness of these bars. Does it have an effect? Add a slider for that. How about changing the color somehow? Can you figure out how to add a color picker to this application? And maybe more complex things as well, like there's a variant of this illusion where these rays in between the bars don't happen, kind of. Can you figure out how to do that? Try, and if you have problems, ask in the comments below or on Discord. Thanks for watching and see you guys.